Hello, everyone. In this video and in the next 3 more videos, I'm going to be covering complex numbers. Complex number, I have seen students struggling in many of my classes dealing with complex numbers. Although complex number manipulation, complex number arithmetic, and understanding, they're very simple. And many of the students, they have already covered complex number in some of the early mathematics class, but either the time when they took the class was too long ago, or they just did not understand them properly. So for some reason, I see a constant struggle in most of my advanced level classes when students are dealing with complex numbers. And they lose a lot of points in their assessment, and many of them actually fail the class just because of complex numbers. So my reason of creating this series of video lectures, I will be creating 4 video lectures on complex numbers. And my intention is that, if you are struggling with complex number, then please go ahead and watch these 4 videos, or whichever relates to you. Just watch those videos and learn about complex number. It's just a review. I'm not going to go into the extensive detail that you may have covered in some of the other classes, especially when you are learning the complex number. So this video series is a review of complex number, and I will also show you some specific uses of complex number that we have in electrical engineering or mechanical engineering, or in general engineering field, because engineering students deal with complex number very frequently. And also, towards the end of this video lecture series, I will be using MATLAB, and I will be showing you how easy it is to manipulate complex numbers using MATLAB. Because again, MATLAB is one of the programming software that is used very commonly in engineering and technology universities and colleges. So let's start. I will be doing, as I said, I will be doing 4 different lectures. And the first lecture, I will be just introducing or going over complex number, what complex number are, how do you represent them in a complex plane, and how to go from different representations. So there are 2 representations. You can represent them in the Cartesian or rectangular coordinate forms. And of course, you can represent them into polar form. So how to go from Cartesian to polar and polar to Cartesian, what do they mean on a complex plane? I will be covering that in lecture number 1. In lecture number 2, I will be covering the arithmetic of complex number, how to do addition, multiplication, subtraction, and division of complex numbers. Lecture number 3 is more specific. Again, if you're not, you're not taking any advanced level engineering classes, then you may skip that lecture. You don't have to watch it. Basically, I will be looking into phasors, which we use in electrical circuits or any class that deals with the sinusoidal, the steady state sinusoidal circuits. So I will be looking into that because those circuits also deal with complex number. Phasor is a complex quantity. And I will be discussing transfer functions that are again represented in terms of complex numbers in engineering classes. And the final lecture is going to be, I will be going over MATLAB and how to deal with complex number in MATLAB. And I will be also showing you a small function that you can write that can convert the polar form into Cartesian form, and how you're going to use that to solve your equations or your complex number arithmetic. Because MATLAB you cannot really, many calculators can deal with both polar form of complex number and rectangular form of complex number in the same equation. But MATLAB, unfortunately, you can only do rectangular form arithmetic of complex number in rectangular form. So first you have to convert the polar form into rectangular. And to do that, the best way is to write a function, as I will show you, and then use that function to perform the arithmetic of the complex numbers. And that makes life very easy. So let's start the first lecture or the first video. I'm going to share, I'm going to open, let's see, whiteboard. So this lecture, we will be going over the basics of complex number. So what are complex numbers? Basically, complex numbers are comprised of real part and imaginary part. So it has two parts. So it's a mathematical quantity, but that mathematical quantity is given by, let's say, if you have a complex number given by z, then z is x plus jy, where x is the real part of the complex number and y is the imaginary part of the complex number, or jy is the imaginary part of the complex number. This is the complex plane. Complex number are located on complex plane. So this is your complex plane. Okay, so how you represent a number on the complex plane? By the way, this is the rectangular or Cartesian form of the complex number. Rectangular, or it's also called Cartesian. So the horizontal axis is the real axis. So you have positive real number here. You have negative real number on the negative x-axis. And vertical axis is the imaginary axis. So you have positive imaginary number here, positive j. You can represent either positive j or positive I, both are used. And negative j. What is j or negative j or I or negative I? Basically, that's the square root of -1. That is represented by either j or I, square root of -1. And again, I'm not going to go into the detail. The intention of this lecture is to do the math and all those things. So without going into the background and everything, a complex number, as I said, can be located in the complex plane. For example, you have 4 quadrants here: the first quadrant, second quadrant, third quadrant, and fourth quadrant. So like you have, a 2-dimensional space, x and y. Similarly, you have a 2-dimensional space here, x and y. However, the space is complex space. So if you have a number in the first quadrant, let's say you have this point, and this point is represented by the real value, which will be this. I assume a number. Let's say this number is 3 on the real axis. And then the number is, let's say I assume this is j2. So this point is going to be 3 plus j2. So positive real number, positive real value, and positive imaginary value. Likewise, if you have a point in the second quadrant, as you can see, the value of real part will be negative. So let's say I have -4. But the value of the imaginary part will still be positive. And I can keep the same value, let's say j2. So this point is going to be -4 plus j2. In the third quadrant, both x value and y value will be negative. So the point is here, let's say. X value is negative, real part is negative, and imaginary part is also negative. Let's assume this number to be -1 minus j. I'll just keep 2. Let's say -1 minus j2. And likewise, in the fourth quadrant, as you can see, the real value are positive, but the imaginary value is negative. So if I have a number, let's say over here, if I have a point, I'll move it down actually. If I have a point here, then let's assume that this is 1.5, half of 3, let's assume. And this is -j3. So this point is going to be 1.5 minus j3. So this is how you represent complex number in Cartesian or rectangular form, and whether the real part is positive or imaginary part is positive or they are negative will tell you in which quadrant the number is located. It is very important that you understand in which quadrant the number is located, because once you convert the rectangular or Cartesian form into what we call polar form. Then if you don't want to make a mistake that actually most of the people make, you have to be careful about in which quadrant your complex number is located. And in accordance with that, you will determine what should be the phase of your complex number. So in polar form, the complex number is given by, let's say, A angle theta. A angle theta. What is A? A is the magnitude of the line that you extend from the origin to the point where the complex number is located. So the length of this line, the magnitude of this line is A. So it's a positive quantity, remember, because you're measuring length. So magnitude can never be negative. So don't make these small mistakes. I have seen some students putting magnitude to be negative. Remember, it's the length. Length cannot be negative. And what is theta? Theta is the angle that you represent from the positive x-axis going counterclockwise. If your point is located in the first or second quadrant, then theta is going to go from 0 to 90 degrees if it is in the first quadrant, and then 90 degrees to 180 degrees if it is in the second quadrant. And if the point is located in the third and the fourth quadrant, then let's say this point, then basically you can still go counterclockwise from positive x-axis, and the angle, corresponding angle is going to be, let's say, this will be the corresponding angle, which will be between 180 degrees and 270 degrees. But it is customary to use, if you are in the third and fourth quadrant, to go from positive x-axis in the clockwise direction. So your angle is going to be between 0 and negative 90 degrees. If you're going clockwise, then you represent angles in terms of negative quantities. So if it is between 0 and negative 90, you are in the fourth quadrant. And if you are between negative 90 and negative 180, you are in the third quadrant. So whichever angle is smaller between 0 and 180 or 0 and negative 180, you represent that angle between either 0 and 180 or 0 and negative 180. So basically in the first and second quadrant, you represent the angle as positive from 0 to 180, positive. And in the third and fourth quadrant, you represent the angle or phase, sometimes we call it phase, some angle, what is the same thing. You represent it as 0 to negative 180 degrees. So your point in the complex domain, in the complex plane, can either be represented by rectangular or Cartesian form or polar form. So for example, if you have a number in rectangular form and you want to convert into polar form, how do you do that? And vice versa, if you have in the polar form and you want to go into rectangular form, how do you do that? So let's look at that. And again, there is something that you will be, you have to be careful about. So let me take a point over here. And again, let's assume that this point is z, which is x plus jy. So let's say this is x and this is jy. And you want to convert this point into polar form. So you want to calculate the phase. Since it is in the first quadrant, you know that the phase is going to be between 0 and 90. And this, make sure you're careful about this thing. Look at the point in the Cartesian form that you're converting into polar form. Then you will know that the angle is going to be either 0 to 90, 90 to 180, 0 to negative 90, or negative 90 to 180. And if your answer does not correspond to that for the angle, then you know that you made a mistake and you go back and check your work. So to calculate the magnitude of this point, and we write down the magnitude as, let's say, magnitude of z. To calculate the magnitude of that point, so I'm representing Z in terms of the magnitude of Z and phase of Z. And I call this phase of Z angle. So to calculate that, magnitude of a complex number from the rectangular coordinates are calculated very easily as the real part square plus only the magnitude of the imaginary part square. Don't put J over here. Only the magnitude of the imaginary part square. Remember, one more thing that you should remember is, remember, I told you that J is the square root of -1. So if you take a square of J, J times J, that is the square root of -1 times the square root of -1, then you're gonna get -1. So that's another, thing that you can do that. But here, when you're converting it, there's no J involved here. Remember, some students take J over here, JY. But make sure, do not take the imaginary number over there. Just the magnitude of real part and magnitude of imaginary part, x squared plus y squared. Now, x can be positive or negative based on where it is located. Y can be positive and negative based on where it is located. But when you take the square of that, remember, that will give you a positive quantity. And that's why the magnitude will always be a positive quantity. So that's going to give you magnitude of the complex number in terms of, when we represent this in terms of the polar form. So this is how you calculate the magnitude. This is very simple, irrespective where x and y are located, that is in which coordinate they're located, in which quadrant they're located. The problem is when you calculate the phase. And this problem comes because the simple calculators, or even if you're calculating using MATLAB using the inverse tangent function, A-tan function, then they don't distinguish between different quadrants, and give you an example. So how do you calculate this? If you go by the trig and you're calculating this angle Z, you know the length of this is Y, and you know the length of this is X. So if you use the trigonometric function, how are you going to calculate this phase in terms of X and Y? Right? This is the opposite side, and this is the adjacent side of the angle. Now we know that tan of angle of Z will be equal to opposite side over adjacent side. That means angle of Z is tangent inverse, or arctan, whatever you want to write down, tangent inverse of Y over X. And again, do not use J over here because it's just the length we are talking about. So that will give you this phase, tangent inverse of Y over X. Very simple, right? And again, be careful about radians and degrees. If you want to give the answer in degrees, then make sure if your calculator is set in degrees, or if you're using MATLAB, then in MATLAB, I will show you in the fourth lecture how to do this. But yeah, just be careful about that. Whichever, either in radians or degrees, whichever domain you're calculating your phase, your calculator is set in that radian or degrees. So in any case, if your point is in the first quadrant, very easy. This is going to give you the correct angle of C, right? So this will be the correct angle. Now, if your point is located in the second quadrant, let's say your point is here, right? And in the second quadrant, now this is your angle right here. So this angle is between 90 and 180 degrees. Now, again, multiple ways to do that. As I showed you over there, you have the length, Y, whatever. I mean, Y is just generic variable, so don't assume it as a number right now. I can put a number as well. And then your length is X. And again, I'm not using negative sign or positive sign because I'm just discussing the length, right, of this right-angled triangle right now. So right-angled triangle, let's say this is the origin, and this is B, and this is C. So right-angled triangle, OBC or OCB, whatever you want to call. And you need to calculate this angle, right? But from the right-angled triangle, you can easily determine what is this angle. So let's say this angle, assume that this point is, whatever point is this. Again, I can call it the same point Z, or I can call it A, is equal to x plus jy. So let's say that this point is A, which is x plus jy, and x, y values are different. It's not the same as here. I'm just taking two variables. They can be substituted by any values. So I'm calculating now the magnitude of A first, right? Magnitude of A is going to be the same. So the length of that line A, now if remember the point, in this case, the point is going to be, and if I want to write down the point, actually, I should write this point as negative x, because of x value is negative, plus jy, right? So the point, actually, the point is going to be negative x plus jy, like negative 3 plus j2. I gave you an example earlier. Now, when you're calculating the magnitude of this point, then it is negative x square plus y square. And again, negative x square is going to be x square and y square will be y square. So magnitude will always be a positive quantity, irrespective in which quadrant it is located. When you're calculating the phase, you're calculating this phase. Now, if you're calculating this phase, there are multiple ways, again, to do it. One way to do it is you take tangent inverse. So you're calculating angle of A. You take tangent inverse of y over negative x. So you have the y value, this, and you have the negative x value. Many people do that. What will be the problem if you're using simple calculator? This is going to give you an angle of negative value between 0 degrees and negative 90 degrees. So not negative 0, negative 0 degrees and negative 90 degrees. That is, it is going to give you the phase right across in the fourth quadrant, and it's going to give you this phase right here. If you use y over negative x, that is this over this whole thing. Okay. Now remember, this is where you have to be smart. Again, if you're using your calculator and if you use y over negative x, the calculator would not know. It's just going to see a negative value over here, and it's going to calculate the inverse tangent of a negative value, and it's going to give you an answer right over here. So, but you know where the point is located, right? You know that the point is located in the second quadrant. So as soon as you will see the angle, let's say the angle it gives you is negative 49 degrees. But you say, well, that's not possible, because the point is located in the second quadrant. The angle has to be between what? 90 degrees and 180 degrees. So observe, if you know this angle, right, then how are you going to calculate this angle, which is the actual angle? All you have to do is to add what? 180 degrees. This whole thing is 180 degrees right here, right? This whole thing is, let me mark it down, this 180 degrees. So if you add 180 degrees plus this, plus means you're subtracting it, right? So 180 minus 49 is going to be whatever is left over here. So what you have to do if you're getting, and you will be getting if you're using the simple calculator, as I said, 180 degrees plus whatever angle is this, tangent inverse of y over negative x, that will be your actual phase A. That will be the phase associated with this point in the polar form. Okay. So again, I have seen many mistakes that students are just going what their calculator is giving them, and the point is here, and they're giving the angle over here, which is incorrect. Again, be careful where the point is located, and then adjust your angle based on that. If you don't want to use negative x and y, if you just want to use length, perfectly fine. You can just do tangent inverse of y over x again, whatever the length is, without going into the negative and j or whatever. And then it's going to give you this angle. So this will be the angle right here, right? This angle. So once again, this is not the angle that, of course, associated with this point in complex plane. You still have to give this angle. So now what you have to do, this whole thing again is 180 degrees. from positive x-axis to negative x-axis, you have to subtract this to find rest of the angle. So now in this case, you are going to go and do 180 degrees minus tangent inverse of y over x, and that will give you the correct angle. All right, so the point that I'm making is, be careful about where your complex point is located in the rectangular form, because when you're converting into the polar form, and if you're using a regular calculator or even simple MATLAB function, tangent inverse, then you will not get the correct angle if your point is located in the second quadrant. You will get the correct angle if the point is located in the first quadrant, but not in the second quadrant. It's going to either give you, if you're using negative x and y over negative x, is going to give you the angle in the fourth quadrant. Then you have to basically, and that's going to be a negative value. So you have to add 180 degrees. And if you're just taking the length to calculate the face of the right angle triangle, then it's going to give you just this face. So you'll have to subtract it from 180 degrees to get the correct angle associated with this point. All right, I hope that this is clear. Now let's move on to the third and fourth quadrant. So in the third quadrant, let's say this is my point C. And as we know, the third quadrant, both x and y are negative. So this is your negative x, and this is negative jy. So in this case, C is equal to negative x minus jy. Again, when you calculate the magnitude of this point to convert into polar form, so the magnitude of this line, that's going to be negative x square plus negative y square, or in other words, it will still be x square plus y square. So magnitude will always be positive, as we know. Come down to the face. If you calculate the face, and remember, now your face is this right here, because the point is located in the third quadrant. So if your face is this, theta, or angle C, whatever you want to call it. I call it angle C to be consistent. This is angle C. All right, so now let's go to tangent inverse. Now again, from the right angle triangle, if this is my face theta, then I can calculate theta using tangent inverse length of y over length of x, without using the negative sign, length of y over length of x, and that will be my theta. But that's this angle. So now again, if you have to provide the angle C, and you already know this, then how are you going to do that? Again, very simple. You are going to do angle C will be equal to negative 180 degrees plus theta. Right? Because the angle is going to be in the third quadrant, that is, it's going to be between negative 90 and negative 180, and you're going clockwise, so your angle is negative. So this angle is going to be negative 180 degrees, which is the complete going clockwise complete angle between the positive x and negative x-axis going clockwise. And then you're going to add this angle, which is a positive angle because you're using positive quantities over here for y and x. So rest of the angle that is left is going to be your required phase. Now, if you want to calculate this angle theta using the actual values of x and y, so you say, okay, I'm going to use tangent inverse of negative y over negative x, right? Then it's going to give you again a positive value, because again, negative over negative is positive. Your calculator will not know in which quadrant you're calculating. It's just going to convert into positive. It's going to give you a positive angle. So basically, it's going to provide you an angle over here, this angle, theta. But you know that this angle is not the actual angle you're looking for. You're looking for the angle, which is this, right? You're looking for this angle. So once again, this line, the angle that this line is comprising is 180 degrees total. And you need to know this angle. You're going clockwise, that is negative. So again, all you have to do is do the same thing, negative 180 degrees plus theta. And that's it's going to subtract this value, and it's going to give you this answer right here, right? Because you're going from here to here clockwise, that is negative 180 degrees. And then you're going to add this value, because this value is going clockwise direction, positive angle. So this whole thing plus this angle is negative 180, this is positive angle. What is left is this angle right here, which is the actual value in the third quadrant. So in this case, both will be same, whichever way you want to do it. So keep in mind, again, be cautious about the location of the point. Location of the point, third quadrant, calculator is going to give you positive value, whether you take negative y over negative x or you take y over x. But you know, it's not a positive angle. It has to be a negative angle between negative 90 degrees and negative 180 degrees. So do the adjustment as required. And the last one is if the point is located in, let me go to the next page. If the point is located in the fourth quadrant right here, and we know in the fourth quadrant, x value is positive. Let's say point is D, x minus jy, x value is positive, and y value is negative. Again, magnitude of this line is simply x squared plus negative y squared, which is simply x squared plus y squared, so always a positive number. And phase is going to be this, because it's in the fourth quadrant, so you're going to go clockwise direction. The angle is supposed to be between 0 and negative 90 degrees, this angle, angle D. And then if you use the tangent inverse function, and simply do negative y over x, then it's going to give you the correct value of D, that is the negative angle between 0 and negative 90 degrees. So you don't have to make any modification. In other words, you don't have to make any modifications if you are going, if the point is located in the first quadrant or fourth quadrant. But you do have to make, or you may have to make modification based on your calculator if the point is located in the third quadrant or fourth quadrant. So keep that in mind. So this is if you're going from Cartesian or rectangular form into the polar form to represent the complex number. Now vice versa, if you're going from polar form, let's say your number is z is equal to a angle theta, and then you are calculating the equivalent value in the rectangular form, right? Now, based on the angle, you will know in which quadrant it's going to be located, right? If the angle is between 0 and 90 degrees, that's first quadrant. If it is between 90 and 180 degrees, that's the second quadrant. If it is negative 90 to 0 to negative 90, that's the fourth quadrant, and negative 90 to negative 180, third quadrant. But you don't really have to be careful about if you're going from polar form to rectangular form. So how you calculate that? Let's say you have a right angle triangle. This is your theta. You're calculating y, and you're calculating x. So from, again, the trigonometric functions that you have learned, how are you going to calculate x? You know this is a, magnitude of this line is a. So what is x? X is a cosine of theta. And again, be careful about theta, which if it is in radians or degrees, because your calculator should be set in that mode. A cosine of theta. And likewise y, which is the opposite side. Opposite side is a sine. So y is a sine of theta. This is very simple. And in this case, you don't really have to worry about where the angle is located. Because if the angle is located in the second quadrant, then this, of course, is going to be between 90 degrees and 180 degrees. And cosine between 90 and 180 degrees will automatically give you a negative value. So x will be negative. But sine between 90 and 180 is still positive. So y will be positive, right? So you don't have to do any modifications. In the second quadrant, y is positive, x is negative. If angle is between negative 90 and negative 180, that is third quadrant, then cosine of angle between -90 and -180 is negative, and sine of -90 and -180, any angle is also negative. So both x and y are gonna be negative values. So the correct value or the correct point in the third quadrant, because x and y are both negative in the third quadrant. And likewise, if you are in the fourth quadrant where x is positive, y is negative, theta is going to be between 0 and -90, and the cosine of 0 and -90 is positive, but the sine between 0 and -90 is negative. So again, x value will be positive and y value will be negative. So you will locate the correct point. So going from the polar form to the rectangular or Cartesian form is very simple. You don't really have to worry about anything. Just go ahead and calculate it using x, a cosine of theta, using the right angle triangle rule, and y is equal to a sine of theta. The only thing that you have to be careful about is when you're going from Cartesian form to polar form, then if your point is located in the second quadrant or third quadrant, then be very careful that your angle is correct. If you're in the first quadrant and fourth quadrant, then your angle will be correct. And always remember, the basic mistake that a student make is whichever units you're representing your angle, your phase, either degrees or radians, then make sure your calculator is set in that phase. All right. So I will continue this in the second lecture, where we're going to discuss the arithmetic of complex numbers.